If you'd like to follow along in this video, be sure to check the description for the link to the companion document, and you can open up this exact same Desmos graph to follow along. We are going to take a look at function combinations using algebra. Here we can see a quick example is f plus g of x, or f of x plus g of x. We'll look at the idea of checking algebraic work. Here I have a simplified result, and we'll check that against the graph that the computer creates by doing the algebra for us. We'll go through addition, subtraction, multiplication, and division, and then look at how we can use compositions as well. I'm starting out with f of x and g of x being a quadratic function, x squared plus 7x plus 6, and g of x a linear function, x plus 1. Go ahead and plot both of those if you want to check them out. Now these initially are the same color, red and solid. Let's start by looking at how we can change those line colors and styles. Here I can make the parabola a dashed blue line and the diagonal a dotted green line to add some distinction for those. For now, let's just make them both black, and I've got one dashed and one dotted. One more quick exercise before we dive into all these folders. This kind of branches off of the last video that I recorded all about functions and tables and graphing. Let's create a table where we evaluate some combinations of these at a point x. I'm going to do that by hitting this add element, click table. For x1, I can choose my inputs. How about I go from -3 all the way to +3, one at a time. So once I get -3 and -2, I can just hit enter, 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 and get all the rest of those. And instead of y, I'm going to change this to a f of x1. I need to do a subscript for that. I usually do shift dash, which is the underscore button. You can also bring up subscripts. That is right here, is A with a small b. Using that keyboard input, really most of the things that you need can be found in that input area. So here I'm going to evaluate f of x1 and subtract, let's start with addition, and add g of x1. And there are the outputted answers to that. So for the first one, f of -3 plus g of -3. I can go through all kinds of different operations. I can tab over and add all kinds of variations. So this is something that I didn't initially have in the document. I wanted to sort of add it as a warm-up exercise here. You can follow along and create these same tables where we evaluate those points. And I'm adding all of these variations, addition, subtraction, multiplication, and division. Finally, I'll have to copy and paste the g of x down below there. We can see that that one's going to be undefined at a certain point. Now I need to zoom out to really view what we've got here. Now we don't really need to see all these plotted points, but you can see that the function is undefined at that x1 equals -1. We have a bunch of different outputs here. You can change the inputs, and it really shows you a way to use the tables, use defined functions and algebraic operations to come up with some results very quickly. This would take a lot longer with a calculator and even longer on paper. I'm going to remove that back out. That wasn't really an essential element of this graph. Now we can look at each piece that we've got here. The first folder, which I'll first just toggle on and off. Let's go back and remove these f of x and g of x lines. This folder contains really just two inputs. The first one where we plot this dashed black line showing the graph of the added functions f of x plus g of x. Here, Desmos is doing the legwork to determine what function results. And the second one is what I came up with when I worked it out on paper, x squared plus 8x plus 7, adding those together, and you can see that these are the exact same. They coincide. Now this is a way that you can check your work. You can graph the result that you got doing your algebra on paper and graph it alongside or coinciding with the defined functions in the graphing calculator. Now each of the rest of these goes through that same thing where we do f of x plus, minus, multiply, and divide by g of x along with the results that I got. This is my scratch work from the homework. The last one is the one that's a bit different. We already saw that that was undefined at x equals -1. I'm going to get this result that is a simplified version, a little bit of factoring and canceling there to get a linear result, linear quotient result. And that is just x plus 6. And we still have to hold on to this discontinuity because even though we simplified it, the original fraction is not going to allow x to be -1 because that would be undefined. So you'll see I'll go ahead and just flip through each of these. When we multiplied them, it was a cubic. And there is that problem where first I put in f of x over g of x as a fraction. And if you actually trace it with your cursor over to -1, you get that undefined result. So it is actually creating a fraction of those, putting a g of -1 and getting a 0 in the denominator there. Now my version that I inputted is just the linear result, x plus 6. Of course, that is going to be continuous everywhere with a domain of -infinity to infinity. So I just noted, at least with one of those lines, in this case I went back to the line that actually would show it when tracing. I put that hole in there as a point. I added a point at -1, 5. I could also use the function result, but it could be a little complicated to input a function within this. So I just figured out what that output would have been. You could have created a new function here. That would also be an option that wouldn't be quite so bad. So I could do h of x equals x plus 6, h of -1, and that will give me that correct result there. Just a way to incorporate a function as an input, looking at a coordinate. You'll also see a use of the backticks around my label to create that kind of nicer looking mathematic coordinate, and then the word whole we use for a break in continuity over a single point. Now closing up that f over g of x, last one is compositions. All I did here was a couple of quick compositions, f of g of x, and then I added in a table to do that just with that function created, that nested function f of g of x, edit the list and click the create table button next to it. And then you can add any points you want. Here, for example, I could start at -10, then go to -9, and then the rest of those are going to fill in automatically. And I can create a table pretty quick with a whole bunch of points. Now, if I want to visualize all of those points, zoom to fit there. It's also, you can see kind of bending these, stretching the axes so that these appear to bend and be more centered in the frame. You can even do f of x as well. Once you've got that defined, you're welcome to nest, as many iterations as you like, or combinations of different functions.